Hello everyone, my name is Marcell Maceno and I'm a professor in the Production Engineering Postgraduate Program at Federal University of Paraná, Brazil. And I'm going to present to us today this article called Photovoltaic Solar Panels End-of-Life, a Comparative Life Cycle Assessment for a Gate-to-Grade Approach. Well, to start, we have a short introduction, okay? And first, photovoltaic solar panel usage has been growing steadily due to the need for alternative energy sources and the benefits of solar energy. In 2022, Brazil added almost 9.3 gigawatt of solar photovoltaic energy, surpassing the previous record and representing over 8% growth. Although photovoltaic solar panel offer numerous benefits, okay, but their life cycle can have environmental impacts. And for example, improper disposal of photovoltaic solar panel can release harmful materials like ruthenium, indium, tellurium, and gallium, which are rare and essential components of photovoltaic solar panels. Well, now about life cycle assessment. Life cycle assessment is a technique used to assess the environmental impacts of a product or service throughout its life cycle. This technique identifies polluting points for water, soil, and in the air. Okay, and this study aims to comparatively evaluate the potential environmental impact of two different scenarios for photovoltaic solar panel disposal using life cycle assessment. Okay, because we have a problem, or we will expect to have a problem in the future because we consume a big amount of this product today, and probably in the future we have a big amount of photovoltaic solar panel to to do a destination. Okay, and this study try to analyze and to understand the potential environmental impact using life cycle assessment in this phase of the life cycle, okay, the destination. Well, methodology. First about life cycle assessment. The research methodology followed uh, ISO 14040 for developing life cycle assessment studies. This standard provides guidelines and principles for conducting life cycle assessment of products, services, and systems, and it ensures a structured and consistent approach to analyzing environmental impacts throughout a product's life cycle. Well, this methodology uh, has four different steps, okay? And we have in the first step definition of objective and scope, and we need to define, for example, the goal of this, the intended application of the study, reasons for the study, functioning unit, reference flow, function of the product system, and a lot of different informations to organize or to pre-organize the study. Okay. In the second step, we have inventory analysis that we have to collect data to produce each inventory in each scenario. Okay. First step, sorry, third step is the life cycle impact assessment, and we apply uh, a life cycle impact assessment methodology to calculate the potential environmental impacts. Okay, and the fourth step uh, is the interpretation of the results. Well, more information about the study. The study aims to conduct a life cycle assessment to identify, quantify, and compare the environmental impacts of PSPs under two scenarios. Okay, scenario number one, we tried to think about, for example, in the future, if we don't have a a minimum structure to send this material. Uh, when I think, for example, here in Brazil, it's pretty common we send this product or this waste to landfills. Okay, and this first scenario is this idea to send all of this product to the landfills. And the second scenario is uh, to analyze a kind of situation that we have a greater uh, um, uh, a kind of a greater use of the materials or reuse or uh, recovery of this material, okay, and consequently we have um, a kind of a division considering landfill 5%, incineration 11%, and recycling 84%. Okay, and other goal and scope definitions are presented in table 1. Well, about product system, it's interesting to see here that we consider only final destination, only post use a step or phase. Okay, we don't consider in this study manufacturing and extracting materials and use of this photovoltaic solar panel, because the idea is try uh, to analyze specifically this phase of the life cycle. And about go and scope, we have different definitions here, okay? And it's interesting to talk about function of the product to produce electricity, okay? The functional unit is to produce almost 11 millions of kilowatt hour of electricity over 25 years, okay? Reference flow, we consider one photovoltaic solar panel for end of life, and system boundary is gate to grave, and the life cycle impact assessment methodology, we use RESP 2016 midpoint, okay, and software OpenLCA. Well, about the inventory, we have different materials: solar glass, aluminum, EVA, Tedlar or PVF, silicon, a sealant, silicon, lead, uh, copper, tin, and silver. Okay, and we have different amounts. For example, in the third column, we have the percentage of each destination, and we consider here recycling, landfill, and incineration. And in the column number 2, we have the total mass of each material. And the column number 4, we have quantity in the destination, considering the percentage in column 3. Well, um, about the results, we have a lot of different uh, amount of potential environmental impact, okay? But in this table, it's interesting to see first that in general, all of the results in each category for the scenario number 1 is uh, is worse than recycling. Okay, the number are uh, greater than the other system, in this case recycling. And another interesting information is about these two uh, impact categories. Category number 10, marine ecotoxicity, and category number 16, terrestrial acidification. And we have the negative value here, okay? In this context, this negative value means for us as a positive environmental impact or positive potential environmental impact. And but it's interesting to see in a graph, okay? And in this graph we have um, it's it's uh, it's easy to see the impact in landfill is greater than the impact of uh, recycling, okay? And we have here the two negative impacts, considering that uh, sorry, those categories, marine ecotoxicity and terrestrial acidification. And we have um, more informations here. For example, scenario number one, with 100 landfill disposal caused the greatest environmental impacts. Scenario number two, with a divided destination between landfill recycling and incineration, caused the smallest environmental impacts. And the results align with Lunardi et al. 2018, which demonstrated that material recovery from solar models reduces environmental impact. Okay, well, to finish this presentation, I would like to talk about conclusions, and we have here, based on the study's finds, recycling has positive environmental benefits for photovoltaic solar panels. Okay, it's important to note that the study employed hypothetical scenarios for photovoltaic solar panel location based on literature finds and the management capacity of each material component. But probably in the real world, this percentage tend to be a little bit uh, less uh, than the hypothetical system, okay? And the real world scenario studies with on-site data collection are necessary to provide greater certainty in potential environmental impact results, okay? And this study can help to optimize research recovery, minimize environmental impacts, and to promote sustainable practices. Well, uh, this is my presentation. I hope you like this study, and if you have any questions, please send me an email. Bye.